Okay. Live, I believe. Let me just confirm. Yeah, not bad. So let's see. There is some things I meant to get to. Just had some trouble getting the stream started this week, but did get a new camera, so that's cool. I can actually see myself instead of looking at the other screen, which makes it look strange like this. You know what I mean? Anyway, since then, since the last stream, I wanted to focus on a specific topic, which is generative UI and agents, UI agents losing context when you have a big task that you're working on. And for that, I came up with some proof of concepts in my sandbox. One very quick one that kind of guided the AI along based on some, some basic thoughts. And another one that was like a little bit more high level with a lot of moving parts and a lot of abstraction. And I wanted to see what it does with when you ask it for a big task like that and don't give it proper setup, I guess is a good way. But it's also beyond setup because you have to create some kind of workflow with multiple agents, basically. And that is basically the core of this stream that I wanted to get to. So let me just show you my sandbox with the two POCs. This one is called Legacy. I guess that's what the AI agent decided to name it, but okay. And this one just uses simple tools that are mapped to the chat. So like when you ask it for something and it picks it up as a tool request, it'll run it. And then the tool is basically connected to the dashboard via state that the chat terminal and the dashboard itself encapsulates. So like basically the dashboard captures the terminal state, and the terminal state feeds the dashboard just enough information to render components, but not the entire stream, because that would overload the app and completely unnecessary, because now you have two copies of the same state without any transformation happening. So let me show you how that works in this app right here real quick. So render, and the issues with it specifically. Render 3 info cards, or 3 block cards, let's go with that. All right. 3 member. So this is a Gen UI mode, that the initial implementation of basically a Gen UI feature for a chat terminal, AI chat terminal, in like a dashboard. So when you talk to it, it updates the UI here, basically, as you just saw. So here's what it did, right? It recognized that I'm asking for it to render something, I guess from these keywords, and it calls 3 tools, well, the same tool 3 times. and all it has is like some parameters for the component, right? And as you can see, the grid is in there, I believe. Yeah, right there. Which is great. But let's say I wanted to render a table, right? Render a table. I'll specify a full width table with a list of team members and other info about members. Make sure the table fills the full row, fills up the entire grid. How do I say this so it understands what I mean? Fills up all columns in the row. Below the team member cards. So I'm being like very specific here, right? Seeing what it's going to do with that information. Because this is a pretty simple implementation, so I don't think it's smart enough to understand how to do all of that. Although I did kind of like try to direct it as much as possible to accomplish that by basically saying, hey, you can set the class name, and there's a Tailwind class, right? I guess that one. But as you can see, it's telling me about the component, right? But it has no concept of the actual grid here, where it does, because it created a new grid. But the grid is, for some reason, a 3-column grid. So like it has like no concept of either making this just a grid or like a flex box, so there's no grid at all, or making this like a full grid span, which you can do with like this, like 1 - 1 or something, right? So I want to know what it is trying here, which is this fucking class, right? Does that even exist? Grid columns. Grid columns. Yeah, it's column span. So it'll be full, which, yeah, this is what I'm looking for, but I don't know why it's not applying it. See that? So that's one issue here. I think what's happening here is there is no Tailwind doesn't have this class registered. So like there's no other component right now on this app that has this class. So because I'm generating it on the fly, Tailwind has no idea that this class even exists, because it like on build time it renders it. So like that's one bad thing about Tailwind. So one thing I can do is force Tailwind to basically render that, or I can have components, like layout components, that the GenUI feature or module makes use of, and the tool or the agent that uses the tool will register these class names or utilities preemptively, so it'll already be registered by Tailwind or by whatever CSS processor you're using. You can even have a custom custom layout class, which I'm probably going to be using anyway. But in the meantime, I can just create a component that has those variants already established. So all you're doing is modifying props. You're not changing class names. But I want it to be flexible enough where class names does work. But again, you run into this issue where the tools and the agents just don't mesh well. There's steps in between that you have to do to like rebuild stuff or have a like dynamic generation process class names somehow through Tailwind if you are using Tailwind. So there's definitely a disconnect here. Although this technically this like solution will work once I figure out the class issue. So I can say, hey, col span full is going to work. So you won't run into this issue. It'll just be like a full width card here. So yes, it's limited to like a grid, CSS grid, but as long as you have all the pieces or all the rules of the grid in play with your tools and your processing, like whatever's processing your style sheets, so it'll dynamically understand all those classes. They'll all be there already. Then this will work, right? This solution will work, and it's a much leaner solution. Or you can, make it a lot more smarter where like this only has specific sets of components. So like once you go beyond cards, you go beyond tables and charts, and you ask to do like an accordion or something more complex than that, right? Like a carousel. If you don't have tools for those, then your GenUI isn't going to work for every request. So like if an end user is using it and they don't know what's available, then your product is going to suck, or your AI tools aren't going to be impressive, because they'll be like, okay, how come this doesn't work? Oh, because you didn't register these tools and all these components, so you have to like basically tell the AI agent by the tools what components they can use and how they can use them. So it's not a flexible process, right? Although it's good for like small scopes or like something specific, like if for example all I wanted to do was list tables, then I can make like an agent that specifically renders tables in various ways. I'll have all the components for those to the pieces of the table, all the functions of the table, like sorting, filtering, etc., like editable columns, resizing, whatever, right? You can go as crazy as you want, and then you focus specifically on that specific thing, like tables, right? But if you want something more robust and flexible and dynamic, like GenUI, as the name implies, where you can basically generate any component that you have in your component library, then it becomes a little bit more complex. How do you solve for something like that? Obviously, you can't, although you can create tools that match every UI component, and that may be cleaner. Like you can probably set up a registry, or use like the ShadCN UI registry as V0 uses, and set up something like that, right? But then the maintenance nightmare of that is multiplied, because not only are you maintaining components now, and however complex your UI library may be, now you're also maintaining the tools to render those components, and you're also maintaining the agents that use those tools. So if you're making changes or adding components, you always have to, maintain those registries and those maps, basically an entire set of libraries to generate UI or keep everything in sync. Not saying that it's a bad approach. Maybe that would be like the cleanest approach if you have a large team, and you can probably automate a lot of that process using AI, like as you're developing. If you have like a bunch of patterns, right, or stories or use cases, then you can take those and tell some kind of agent to create tools for those components and all of that, following like a specific set of instructions and examples, using existing tools and functions, whatever that may be, for rendering components, right? But if you're speaking specifically about like Gen UI or what it means, you do want some kind of smart solution for it, right? So that's brings me to my second POC. And this one was like a little more hands off. It was mainly feeding it information, like a little bit of planning and notes, just high level notes that I gave it initially. And I did tell it to work within my code base, so that could have influenced a lot of the decisions of how this was made. But the results themselves are interesting. I mean, the solution does not work, but it's with a little bit of cleanup, a little bit of tweaking, I think it can get there. And I guess what I want to see is if this would be a smarter approach than the one I just described earlier. So that's kind of what I'm trying to figure out as well as I'm working through this. So I switched over to the agent mode, which is like where I connected this second POC to. So this first iteration is connected to this Gen UI mode, where it just updates a component in this dashboard, right? And this mode is technically supposed to modify this component here, but it doesn't work right now. I need to basically review the code more thoroughly, and because I was very hands off on it, and figure out where the disconnect is. Most of the time, it's related to calling the store, which I am using like a KGoT store or atomic state to render the dashboard, and the AI API calls themselves through this interface here are handled on the server. So I'm guessing that's where the disconnect is happening. And I mean, I solved that here, so I probably just have to do the same here. I just got to figure out where that is, because man, the AI generates so much code on this. It's kind of crazy, but kind of interesting too to take a look at and understand what's happening and why it's doing this. So let me ask it to first tell me about your Gen UI capabilities. This is the agent that is connected to that Gen UI package. Maybe this will give you like a high-level idea of what's going on here, or how this was set up. And it's saying I have Generative UI function. So it's calling a single function or tool. And then this tool basically coordinates different agents or sub-agents that talk to each other and use their own tools to basically create to generate some kind of user interface based on the instructions. So here's what it's saying: UI component generation modification, create cards, charts, tables. See, like it's saying on the dashboard, but this is a package, so I don't know why it would assume it would be on a dashboard. That's what I got to fix as well. See, like when you're hands off with these kind of like big requests, they don't turn out well. And that's kind of what I wanted to show here, that cleaning this up would be difficult, but you are seeing like a lot of what you're basically doing is you're running through ideas in your head, like that you normally would run in your head and then test with POCs, which is proof of concepts. But you're doing this in a much faster way and in a much lazier way, where you can, input a bunch of high-level parameters and instructions, and you can have some specs and examples to work off of. And hopefully you'll get like at least, I don't know, 80% of what you need, and then fix the rest. And that'll get you started, and it'll help you understand what's needed and what's not, and what's a little bit too crazy or too over-engineered, and how it can be simplified, as I showed on these, two different scenarios or examples, or I'm showing you right now. But basically, from these experiments that you normally would do yourself, and you'll spend like, I don't know, a few hours to a few days, depending on how big of the feature you're working on. So you're doing this in like a matter of hours now, and you're learning from those experiments, because you can basically say, or you can basically tell what's working, what isn't, and what's easier to implement, and how to do it better. So like on your next iteration, on your next idea, you can take what you learned and formulate a better request or a better prompt, or specs, whatever it is you feed your agent, preferably specs. And you give it a little bit more direction. You have, I don't know, you have agents for architecture, you have agents for all your dependencies, like all the patterns to use based on the docs, depending on what version of those dependencies you're using, et cetera, the community standards. So like you have agents to handle all that, right? And as you're iterating over these POCs yourself, as like in like the sandbox environment, you're getting to your ideal state of your feature. So like you're basically getting to version 1 way earlier than you normally would, because you're letting the AI handle the POC, and you're managing it, or you're developing it on like a higher level. So let me see what it's saying here first, just so I don't digress too far. So how it works: generate after 6 parameters, request. Okay, so so I'm not doing any of these, because the function itself is ran by the interface agent, or the GenUI agent here, just the agent for now, but essentially it's a GenUI agent. And what that agent does is it translates user input, captures user intent, and it creates instructions. And in this case, it's for this function, right? So it extracts the request, it extracts the other options, and the sub agents, because I'll tell it a simple thing like we did before: render 3. See, so it's running the Generative UI function or tool. Before, in the GenUI mode, as you saw, all it did is call tools for like create a card, create a table, right? And it handled each request at a time. So like if you asked it to generate 3 cards, it'll run the tool 3 times. And beneath that layer, it'll decide how to do that based on like how the state is set up. So like all of that is abstracted from the tool itself. The only thing the tool that returns in the previous version is some properties, right? And then the properties are mapped to the actual components and the state in like the background, like the actual functionality that handles that. And that's completely separated from the AI calling the tool. So that's a nice approach, but yeah, it's more difficult. It's like it's more work, it's more labor to set up. This approach, I'm trying to basically have agents handle all of that. So like you like low-level tools that are mapped to like high-level functions, basically to create whatever whatever layout or interface that you want. It could be complex, but for now I'm trying to get something simple to work, which is these 3 cards, which the AI supposedly understands, like it has that info, but the dashboard, as I said before, is disconnected because that state is not being communicated to the app from the package. So like the package has its own internal state and an internal agent that handles that state, right? It's a sub agent, but the app itself has no idea how that even exists. Like it's basically waiting for output, which it's not getting here for some reason. So I have a lot of data here, right? As you can see, that's being recorded in this output, this tool output, which is the generate UI function. And this is massive. See, like, I don't know if all of that is necessary. And that's another issue that you'll find with asking AI to handle big tasks like this without breaking them down and doing it step by step and knowing exactly how it's going to work. But then again, how would you know without trying it, right? So I am running a POC and already I caught this problem here. So the problem is, yes, the tool is run, but why does that matter? All I really want to see here is all of these results. Like I want a breakdown of these. So what I need is like a component that is not just documenting one tool call, but the component tracks the sub agent workflow basicly. So like the agentic workflow, I was going to call it. So like agent workflow component would be a good or like output would be a good name for it. I don't know, but what it will show is like a second stream of updates of like how these agents are interacting. And this is something that would live in that Gen UI package that you can just kind of plug into your AI chat interface here, this section here. So instead of showing like all of this, it'll show it like step by step, and I can like zoom into it and see what each step does and how each step is taken to the next. So like how each agent handles the request. All of that is kind of lost in this one big JSON object or array, which needs to be broken up into tasks. And that way you can triage it better, and you can also maintain you can sort of see how the agents work with each other. So it'll be like more like an agentic triage component or something like that. So again, also there was an error where like the maximum update depths exceeded. So basically there's too much info coming in and too many updates happening. If I'm sure if I use some tools to debug it, I can see how, you know, it's basically a loop, right? And then since each agent has like its own loop, you're basically running loops within loops. So I'd have to reduce the number of I have to basically exit some of these loops a lot faster. So a lot of these agents that are like creating components or updating state, they need to run only once. So I need to exit out of those loops once they're done. So there's like a lot of work still goes into it. Yes, it's more dynamic, it's more flexible, it's more smarter, and it's using the KGoT paradigm, which is I'll talk about that later. But it's basically the knowledge graph of thoughts, which is how you maintain agent thoughts. So if you're running multiple agents, you can have like a reference to that, to how each agent thinks. So whenever the next agent picks up the work, they know what happened basically. So you're constantly sharing the output results with each agent, so they're always kept in the loop of what is going on, like how these agents supposed to talk to each other. They don't know what's going on. It's like they can only base it off of results. So you either give it proper input, or you ideally do both. You give proper input, and you also give it like a reference to the thoughts, and then the actual orchestrator or coordinator agent, the main interface agent that runs all these sub-agents together, also has like a context of what is going on. So it's not kept in the dark. So it knows exactly what each agent does, what it's thinking, how it handled it, and then it'll basically piece all that information together. Ideally, I think that's the best approach, like long-term solution for like a proper Gen UI agent that has access to an official registry that you have. So like it knows exactly how each component in the user interface library is registered, like where its code is found. It also has like references to like examples or larger blocks that are using these lower level components together to like piece together different patterns. So like you have an entire registry for that. And that's I think that's probably one of the main ways that it'll work. Like without that registry, you're kind of still shooting in the dark. And unless you want your agent to spend time reading docs and browsing the web for examples, you just use your registry instead. So like you have proper guidance from developers and designers on how to use these components and how to put them together. So yeah, as you can see, a lot of operations happen. There's a lot of steps in this entire process. There's responses from the model. So it's using a lot more tokens for sure. It's using a lot of making a lot more requests. So if you have too many, it'll break like it did here. And yeah, it works. I think internally it works because I'm seeing all this data, right? And it's spinning back how these cards are going to look. But again, it didn't finish its response. It kind of errored out because it ran out of, kind of just crashed because of like infinite loops, basically, because all these agents are basically loops, and they were not exited out properly. So it ran out of memory. Not a scalable solution. So like, at least for this iteration, you can definitely like handle it, like I said before, parse this out into steps. So you can triage each interaction with agents, have each agent to have like end an operation. So you're not like running into call stack issues like React is complaining about here. And you're exiting out of those agent loops once the agent finishes its work. So like you're not wasting, you're doing a lot of garbage cleanup or memory cleanup, which is annoying and hard to debug. You probably want to debug this in like a terminal somewhere in your code, not in the app. But for this specific use case, we're doing this for now. But yeah, as far as which approach to take, again, it's really up to you. But for me personally, I think I'm going to start with the smaller level approach, where like a very simple tool method, where the tools are refined to do specifically one thing, for example, tables. And I would focus on some kind of agent that does stuff with tables. So I would handle on that level for now. And as I build up these patterns, right, I can essentially create a registry in parallel, because the only way that the second iteration, the more complex iteration, will work is if you have a registry that the agent has access to. And if you're doing it through, if you're doing like an app interface like this, the registry has to be on the URL. So like chatcn UI would be a good example. So I would start with that, which I am already using. So I would create my own custom registry based on their docs on how to do those, publish it on the URL. I would make it public for now, but if you need something private, there's ways to do that. You can basically make your registry private and authenticate your tool as you're using your agent. There's definitely ways you can do that safely. So I would start there. Low-level tool based on specific needs. Like for example, I want to render a list of people in a table with specific columns. I want to be able to sort them. I want to create like a printable version of it, and I want to be able to modify the rows. Like if I click into a row, I can change it or have the AI change it. And obviously some like layout stuff, like I mentioned before. Make sure the layout works. So like these layout classes are already added to the Tailwind source. Since I'm using Tailwind, I'm gonna have to add them to the source. So like if I am rendering it on the fly and like a class doesn't exist, it still works because the source is already mapped to like the layout classes that I need. And there's ways to do that. Pretty easy ways to do that. And then so this is the approach that I'm going to take, and because the other approach would basically take too long. You can do it if that's all you want to do, right? But that's not all I want to do. I don't want to spend like, I don't know, however many months building a Gen UI workflow and feature and all of this, making it dynamic, creating a registry, spending all that time, debugging and figuring it out. And then by the time I'm done, all I really have is a tool that, I don't know, yeah, I can render a bunch of components, but I could spend that time writing them internally, using my own internal agentic workflows that are more efficient than if I were to create an app interface for. So it's whatever it is you want to solve for, right? Although I do eventually want a tool like that, because it'll make this whole Gen UI thing more flexible. So like if I want to go beyond the tools I already have, like tables, instead of building another set of I don't know, like specific component blocks that are like not flexible enough, they have to have patterns, preset patterns basically, instead of dynamic ones, then yeah, eventually I would need some kind of tool like that, right? And the best way to do it is iteratively, through establishing the patterns so you can guide your agents, keep it on rails, and iterate over POCs a lot more efficiently, because you already have like your patterns defined for how this should work. And yeah, building out a registry, again, automating most of it, but initially you need some patterns to set up. Like you need a bunch of examples of tables, so you need to build a bunch of table components in various instances. I guess you can write some stories or documentations for it, but probably the best thing to do would be create some apps or tools, like low-level tools, and isolating them, and then creating a registry off of those packages. So either way, you're doing work, and either way, you're not going to magically, get 100% output from your agent without doing a lot of this work, without cleaning up a lot of this mess, right? And I guess that's the whole moral, I guess, of this story, if you want to call it that. That things may seem magical, right, and impressive at first glance, but to make it sustainable and efficient, scalable, and I guess dynamic and smart, then there's a lot of work that goes into that I think a lot of people kind of overlook, especially when they're talking about AI replacing software engineers. Yes, there's a lot of stuff that gets automated, like running tests or doing small fixes here and there. But all you're doing is you're improving the efficiency of your engineer, because they know specifically how that code works already, and they know how to fix it and what to do. So you're giving like very specific instructions, and you're overseeing the results of that input, and you're guiding it along to the result that is required of the product team, that the product team requires of the developer. So I wouldn't replace your engineers just yet, is what I'm saying. If anything, I would give them more time to solve problems like this, because setting up a knowledge graph of thoughts, it's not easy, It's essential for sure for most AI apps that deal with a lot of data and a lot of dynamic information. For example, like if you need generative UI, generative dashboards, a knowledge graph of thoughts is essential if you're creating agents with sub-agent workflows that need to communicate, because ideally you restrict yourself to like a few agents, but what if you want multiple agents talking to each other, because eventually you might need that. Then you're using this paradigm to basically manage the state and manage the workflow of the agents as you would like a specific dev team, but it's happening in real time. It's not happening in the lab, basically in a development environment. It's happening in production using like high level abstractions, using low level components. It's not easy, because you are keeping it on rails. You're as you see here, like this dashboard does not understand whatever this is, because all of this needs to be broken up as well. Because how does the state agent understand the component agent? Because the state agent is like a higher in the hierarchy, because the state agent must know what properties a component has. The component itself might not care about the state, because all it needs is the properties to display, right? But the state agent needs to understand how many components there will be, what each component's state is, blah, blah, blah. So like when you're asking it to change a specific component, you understand which one you're changing and what part of it you're changing. And on the level above that is like the coordinator or the orchestrator of all of that, and that's interfacing with the user. So the user's input has to be translated for the agents to understand what to do, because they all function specifically. They all have their own tools, but they have to basically get the job done. So you gotta think about it on that level. You're kind of like in a sense, you're a product manager, right? Or the coordinator, the agent coordinator is the product manager, and you're like the owner or the client, and you're telling them what to do in real time. It's a pretty cool concept, though. So it's still a lot of work. So either way, I am not saving time. So what I will focus on, which is for like on my size, my scale, something smaller like this makes more sense, because I can fix the class issue and stretch this component out, and I have what I need for my use case. But eventually I will need something bigger like this, and I got to break down that work basically, because the level of effort is too high, and I will need to process it or do it in chunks. And I need to spend some time thinking about it, and I may have to do several more proof of concepts of specific parts of that code to do it properly, because I don't know if I'm going to use, JOTI for handling the graph of knowledge, because I don't need that. I only need JOTI for front-end state, right? So I need some kind of back-end for graphs, like a graph database, graph storage database. So I need to find a good open source graph data storage for that to handle it, and then communicate it to my front-end state, basically. All right. I guess I can go over a little bit of the code, since a lot of this will probably make more sense looking at that. Let's see. So first is a Gen UI mode. And to do that, I have this route, this API route in the next app. And this is just a stream text with a prompt, passing in some messages. I'm passing in a model, and it's a basic, loop for streaming UI. And it has all these tools, right? Create card, create chart. So like all it's doing is creating and updating stuff. And the components for that are right here. So I'm just using, low-level UI components to piece this together. And there's like different types of cards that I can render, and the variant controls which content type is rendered. So it's like a very very static way of doing it. And I don't know if I might change this a little bit more, but we'll get to that, right? But for now, this is how it works. And this component right here is supposed to be like like a layout piece, to create the layout for these smaller components. So like the wrapper that creates the grid, for example, for 3 cards, and you're told to render 3 cards. And it mainly works with this hook, which, processes these components using the tool, processes the tools into components, and like uses a state to update the dashboard. This is where all that happens. And that only happens here if the mode is Gen UI that it does this. And this UI generator component is basically determines how to render the components in the dashboard. Otherwise, it shows this message, right? So it's using this here, and that checks the state, which the tools themselves are updating, right, in this hook. Then you got The actual tools for each of these components, as I mentioned before, yeah, you got a lot more tools. You basically need a tool for every component, possibly a tool for different parts of the component, depending on how complex it is, right? And maybe you need tools to like switch out pieces of it, like if that's the approach you want to make, which probably might be a good way to do it. Like you have artifacts or patterns for how a card is supposed to look. So like if you're telling it to render a card for a shop, you have cards that are specifically for products and stuff like that. And then maybe you want like, I don't know, like cards for like a dashboard, then it'll look different, right? So like you'd have different classifications of cards. You still need to register all that, or you still need to define all that. Best way to do it is register. So I guess either way, you are looking at a registry here. So either way you do it, some kind of registry to like basically connect tools to the components. It's almost like another iteration of a component, right? Because see, you need this. This is the registry basically. This is what's going to be registered for a specific request. So like in the registry or in the tool will check the registry for patterns under that request, and it'll basically make a smart decision which one to take and render. So not as easy as you thought, right? Even though it is simple compared to the other option that I showed you. But still, probably the more lean or the more agile approach is this, I would say. Then you have, then you have the GenUI agent, right? And this is a lot more dynamic. So it has no concept of, well, it actually does. Where is this coming from? Okay, so see, again, I didn't tell it to do that, but I guess it's still, like I said, it still requires a registry. But again, it's a little bit more high level, or at least the direction I told it to go. But you know, the AI is not gonna care. it's gonna make something up like it did here. So here's what it made up. I mean, you have the renderer, right, for blocks, which I sort of said like, hey, sometimes these components are gonna be blocks, which I probably shouldn't have. I should have probably stuck with a simple example. So my fault. Then you have component rendering. So like in this case, it should be just, this should just be like a generic component, like GenUI component, and then it'll pass props, and then the magic happens in there based on that data from the tools, where it'll like dynamically render registered patterns, or it'll create one, right? It'll like register that pattern through the workflow, agentic workflow, or like generate HTML, or like Markdown. Like, so let's say Markdown might be a good one. Again, still a lot of thoughts in there that I need to understand, but let's say it's going to be patterns. So it'll choose from a set of patterns to create the component, or it'll put them together using like lower level registered patterns to create like a component or a block. It'll register that in like another section of the registry, and then I guess pull it in and render it. So like there'll need to be some kind of rendering engine that renders code dynamically. So that's another part that needs to be figured out. So it's not going to, unless you have it registered to the state, like I'm trying to do it on this part. So man, still a lot of thinking to do. But let me just show you the GenUI library though, because that's what it's using, right? So this is the agent API route, and Okay, so I have some tools. Interesting. So I think these are old. I don't have, these don't work basically, but this is the only one that is relevant for this part, for this piece, for what we're talking about. And it's basically saying, it's basically that Gen UI function that was listed here, right, in the terminal in the app. And it is interfacing with a bunch of agents here and waiting for their results. I'm guessing it's using these results. Okay. So there's still a lot of work here, right? That needs to happen. As I said before, like chunking this out and ending the loops is one thing that needs to happen. But essentially this package was what kind of came out of this idea. And it's massive, as you can see. And I don't know if it should be that massive, but initially I had a couple of agents, but then I fed it more and more information and it kind of evolved from there. So not a good workflow again. I should have done more time planning and maybe breaking this up into chunks, but again, it is what it is. And there's a lot of info to clean up, like for example, graph. I don't know if we need a graph for the front end. So there has to be some kind of factory or rendering engine that uses that runs on the back end. And I think that's the piece that I'm missing to make this work, because I try to make this work on the front end mostly, and that's not a good idea when you're dealing with a bunch of agents which are basically running on the server. So you want to handle a lot of these operations on the server and then just stream updates to the user as it's happening. So the user isn't stuck sitting there looking at like a big tool call. It's seeing the process happen over time, and there's updates. In like, if you think about it, it's like a bunch of sprints, but in a hyper scenario. So like you're not waiting months for the developer to update you, or the development team, product team to update you as a client. You're getting it quick. So like the first few tool calls or the first few agents would basically be like, I don't know, like the first few weeks. So that's what you're experiencing. Or that's the general idea behind all of this, right? So you're with Gen UI, you're kind of like developing in hyperspace or hyperspeed, and you kind of break those steps up and handle all that information and hold all that context and knowledge and streams of each agent tasks and how they solved it. Maybe you want to like keep looping. You have to like stop some operations, like because there's blockers, right? So like until this agent figures it out in this loop, those agents can't do anything. So you want to stop those operations to save resources or time, or I don't know, getting confused or getting poor unsynced results. So there's a lot of stuff that needs to happen there in the background. So you do need a strong backend with a graph storage database. So like whatever this is that it attempted to do using TypeScript. I mean, it's good for like trying to understand what's going on, but it's not going to work. It's just not going to work, you know, because you need a backend to handle all this. And this is basically a React package. See? So maybe it should be a Next package. You're going to make backend, but then I don't want to use Next for something like this. I probably want to use Python, or I don't know, like Node or something. probably going to use like a graph storage database. And I think a lot of those are in Python. There might be some in with TypeScript that work, so I'll probably try out those first just to keep this project TypeScript. Let's see. So we have all these types. There's like an agent type, graph type, state, which is basically components, like layout, components, blocks. You got the theme, because I wanted to have the agent control the theme of the entire app or the dashboard. So again, not really focused. So let's look at the tools. It has tools broken up by these classes, right? So I have a theme tools to apply the theme, create themes. This one just creates the tool set, and then setting. So they're like CRUD operations, and then other utility operations to like create sets of tools that can be reused quickly, and with state, with shared state or context. There we go. And then state is just front end state, right? Like KGoT. Before, this is not a React, just like a basic TypeScript package. I added React to it, like on the second or third iteration. This one updates the layout, which I don't know if it works or not, and I don't know if we even need it. Like this is something that's okay. Do we need? Probably, yeah, because first you want to like have the agent set up the layout. If you're looking at it from that perspective, like, hey, what is the layout going to look like? And maybe that agent has some questions that need to be answered that it'll relay to the coordinator agent, and then that agent will ask the user, get some info, and then transform that, and then feed it to the requesting agent, in this case the layout agent, to like either create some kind of layout or make some updates to the layout based on the user's continuous input. KGoT, this is recent, because I fed it some more info about knowledge graph of thoughts. So just to like simplify this entire package, but I don't know, I think I just made it a little bit more complicated. What I should have done is create a new package just with that idea in mind, which I'm definitely going to try at another point once I integrate some kind of graph database to work with, because this will need a graph database to create or map, store, and agentic workflow thoughts, memories, to make the your sub agents work as a team, basically. So man, this is going to take a lot of work, but as I said, I'm not going to do this right away because this is way too complicated. And then blocks are just like a higher level of components that puts a bunch of components together in like a specific pattern. For example, like a like a dashboard, or like a home page hero, or I don't know, maybe like a store page that lists products with filters and all that shit, something like that. And I still need to classify what those are, because you have your low level components, right, in your component library, and then you have your registry that maps to that, and then you have your set of tools that map to the registry. But then you also have patterns, so you got to like create blocks of components. You have to have different versions of components. So like you're using little UI pieces to create components. So like, hey, this card is this. There's a bunch of cards like this. So yeah, there's going to be like higher orders of these patterns that need to be registered or created. So like components, blocks, views, entire apps. I think you would call those artifacts at that point if they're entire apps, because they have like different folders and modules kind of configured together. So aside from these tools, you got your store, which is using JOTA in this case, but the store is basically a reflection of these types and tools in a sense. And then you have your registries, which again, I didn't even tell it about registries, kind of just figured it out that it needs a registry. So this is sort of like what it would look like, but obviously the schema for the registry would be a lot more complicated, as I mentioned before, because you'll have different endpoints or URLs where these component pieces live, and then you have UIs that comprise different types of components together in different patterns and blocks. So all of that needs to be mapped out and organized, so your agents understand what it is they're looking at, or your CLI commands, whatever it is you're using for your registry. Agent coordinator, I think this is from previously, but this is basically it's telling it how to use each agent based on some of these parameters, based on the context you're giving it. And then you have controllers. So this is new from the KGoT pattern. These are basically controlling the UI or the view. And then you got the agents, right? So there's way too many agents. So I think the main problem with this is like too many agents. So I would have to simplify this into like maybe like 3 or 4 agents, and have them do like very limited things. I don't want them to have too many tools and too many operations to think of. I want to keep it as simple as possible. And then you got these adapters. I think before is like if you have your own state, you can adapt your own state to these components. Again, like another layer of complexity that's not needed for this version. Yeah, as you can see, this package is massive, and it doesn't work. It's a good idea. It's a good start. So like I'll be able to review this a lot more in depth, maybe even like document some things, and then run it through like some AI prompts to analyze the code, and then out of that will emerge like another plan. And like aside from that, I'll have my own ideas based on some research that I did of how to create these patterns, and basically package them together and connect them to like a knowledge graph on the back end. So your AI agents are actually solving problems in the back end, and they're streaming in very small amounts of information. So you're not overloading your UI. You're only getting it just the right amount of like high level information that the user can look at and understand what's happening. So they're not looking at just like a very long loading screen. So yeah, all of that needs to happen. And step 1 is based on just on this week of trying to figure this out and see like test out these different proof of concepts. Again, I landed on what I already knew, and that is not already knew, but I kind of suspected. I just need a confirmation. So, and that is I need a registry that kind of like maps to my UI. So since the UI is like a very low level pieces, and you kind of like put them together, I need a registry that maps all those pieces together, but I also need to build on top of that registry and create more complex patterns, like for example, like the cards, the different set of cards, like blog cards, product cards, info cards, team member cards. All of those are like different patterns of cards. Completely need to create those. You need to create different types of tables with functionality that's common, like filtering, sorting, all of that, editable columns, etc., etc. And then go from there. Charts, different types of charts for different types of data. Different colors. So like you basically have to learn an entire chart library. I'm using Rechart, so I have to like go in and read those docs, and then have an entire day or a couple of days, probably a week, just dedicated to charts alone. So yeah, as you can see, registry is the next big step. And if I just focus only on that, I'm not gonna have much progress. All I'm gonna have is a bunch of like good work, but in terms of product or satisfying the client's need for something immediate, because unfortunately that's the way things work. You're not going to have much to show for it. You're just going to have a bunch of code and a bunch of like abstract, data streams, and that may be very important and useful to people that deal with that kind of low level information or low level patterns, but it's going to be useless for somebody that wants a dashboard that renders cards and tables and charts. So what needs to happen is, in parallel to creating these registries for the components, I also need to focus on creating this thing right here, this working piece, which is mapping components using tools to a grid. So it's a little bit less complicated, right? Because you're creating low-level tools, but you're also creating patterns that you can create a registry out of later. So as you're working on this feature in parallel, you can also show your client, hey, you actually have something here. You have a table that I can look at, and I can actually take this table and create like a very small, low-level app that renders tables for anyone that needs it, right? So you already have a working product in a sense. You have a concept, an MVP, and you're building on top of it. You're not just stuck in a mountain building a big monolith that people are going to be waiting on for months or probably years. And then by the time you're done building it, maybe somebody else already jumped to market quickly and created like something that looks like the thing you're building, but it may not be the same thing on the low level. Maybe your code is way better, but nobody will care because they won't see it. They'll see the table and the cards and they'll be impressed by that. So that's the gist of it. You got to basically start small and build on top of it. You can't spend too much time on a massive task, even though that might be the right approach. It might not be the one that gives your product a brand. It'll elevate your idea from just a concept to an actual brand that people want to use. So yeah, that's pretty much what I wanted to talk about today. I hope you're kind of got what I said, but if not, you will eventually as I stream some more of my progress and I guess organize my ideas a little bit better. And I plan to make some short form videos at some point too, but for now I'm just streaming my workflow and streaming my thoughts mainly, and kind of trying to get the hang of video content or stream content in general, because it's new to me. All right, I think I'll be signing off for the day. Until next time.